Ever tripped over a shoelace and missed your bus? Then, because you missed your bus, you ran into an old friend, and that chance meeting led to, well, who knows what. It's like that saying, missing one thing
leads to missing another.
Exactly. But today, we're taking that idea to a whole new level with the butterfly effect. We've all heard the phrase, but you sent in this really interesting excerpt on it, and honestly, it's way more than just a cool saying. So today, we're going deep, unpacking where it came from, the science behind it, chaos theory, and maybe even more importantly, why it still matters beyond just quirky weather reports. And to kick things off, we got to rewind to the 1960s. Picture a meteorologist named Edward Lorenz just hard at work trying to predict the weather. You know, no fancy tech back then, just him and his computer. But what he stumbles across changes things in a huge way. So what exactly was Lorenz trying to figure out? And what unexpected wrench got thrown into his research?
Well, he was running some of the very first weather simulations, feeding all sorts of data into his computer, like temperature, wind speed, the works. Then one day, he's rerunning a simulation, and, to save a little time, he rounds off some of the decimal points in the initial data. Just tiny changes, right? I mean, you'd think the results would be almost identical.
Yeah.
Well, they weren't. Not even close.
And that's where we go from, Tuesday will be cloudy to, hold on a second.
Precisely. The simulations went totally haywire. Turns out, those absolutely tiny variations at the start created wildly different outcomes in his model. It's like Lorenz realized this wasn't just a computer glitch, It was pointing to something way more significant about how some systems just behave.
Okay, so we're not talking about, my sock drawer being disorganized. This is chaos with a capital C, right?
Exactly. That's what this is. Lorenz's work really set the stage for chaos theory, this whole branch of science that focuses on systems incredibly sensitive to their starting conditions.
Okay, I think I'm starting to get it. But do you have a real-world example of this sensitive dependence thing?
Sure. Imagine trying to predict, where a billiard ball will end up after, say, 5 or 6 collisions.
Okay.
Even the tiniest difference in the very first angle you hit it can drastically change where it ends up.
Okay, yeah, I'm with you on that billiard ball example. Even I can picture that getting pretty unpredictable pretty fast.
Right, exactly.
But let's bring this back to the weather, because that's where all of this started, right? What does this sensitive dependence actually look like when we're talking about, rain or shine?
Okay, well, think of it this way. Even the smallest, tiniest gust of wind, something we might not even feel, can influence whether a cloud forms or not.
Oh, interesting. Okay.
And that one cloud, depending on a million other things, it might end up leading to a rain shower in one town, but not the next town over. That, all those tiny little variations, they just keep adding up over time, and eventually you get huge differences in weather patterns across the globe.
Wow. So it's true then what they say about a butterfly flapping its wings in Brazil causing a tornado in Texas? Because I remember you mentioning earlier that our source material used that example.
Right, exactly. Now, of course, it's not like one single butterfly is out there causing tornadoes on purpose.
Go ahead.
It's more that. It's tiny little disturbance, just adds to all those other interactions happening in the atmosphere, and those effects just kind of ripple outward.
So it's not quite as simple as a direct cause and effect thing.
Right, yeah, it's not a one-one.
More like a chain reaction, but on a global scale. Okay, so we've talked about weather, but your notes also mentioned that the butterfly effect kind of pops up in other areas as well, some surprising places too, so I'm curious.
Oh, absolutely. Take economics, for example. Let's say one country, makes a small change to their interest rates. That can have a ripple effect on global investment, which could lead to a boom.
Oh.
Or, the opposite, a recession.
It's kind of like what happened back in 2008, right, with the housing crisis.
Exactly. It seemed like an isolated issue just in the U.S. housing market, but it snowballed into this global thing.
Wild. Thinking about it like this, it's kind of unnerving. This whole idea that even one seemingly small event could snowball and have all these huge consequences down the line.
Right.
But does that mean that everything has the potential to cause chaos? Every decision we make? So that's the million-dollar question then, right? If I spill my coffee this morning, should I be worried about setting off some crazy chain of events?
Well, that's where things get a little more, nuanced. It's not like the butterfly effect means the entire world is one spilled latte away from complete disaster. You know what I mean?
Okay, good to know.
It's really more about understanding that certain systems are way more sensitive to change than others. Not every system is in this constant state of potential chaos.
Okay, that makes sense. But how can we tell the difference? What makes one event, butterfly effect worthy, Another one, well, just another Tuesday.
Yeah, that's a big question.
Yeah.
You know, I think the source material actually had a really interesting comparison about this. They talked about, like, the assassination of Archduke Franz Ferdinand.
Yeah.
You know, the event that basically sparked World War I.
Right. Huge historical impact.
Exactly.
Yeah.
And they contrasted that with something as small as, like, dropping a pencil. One had massive ripple effects that changed the course of history. The other, well, you might get a dent in your floor, but that's probably it.
Yeah, I see what you mean. Context is key.
Yeah.
But, that historical example, it makes me think about how often we see the butterfly effect pop up in stories, too, Like, in that classic time travel story you mentioned, A Sound of Thunder, that was in the source material as well. What do you make of that connection?
Oh, that's a great point. I think those kinds of stories, they really tap into our fascination with cause and effect, with this idea that even the smallest actions can have these huge unintended consequences. Like, step on a butterfly, accidentally change the entire future of humanity.
Right, goes from 0 to 60 pretty fast.
Right, and I get that. But obviously that's a pretty extreme example,
Right.
But it does seem to reflect this very real anxiety we have about, like, how much control do we really have in a world this complex?
It's that whole what if I'd done things differently thing, but on a global scale. I like it. So as we start to wrap up here, what's the one big thing you hope our listeners take away from all of this?
Well, more than anything, I hope it just gets people thinking about the butterfly effect as more than just a catchy saying. Lorenz's work, it really did revolutionize how we view these chaotic systems. But at the same time, and your source material really highlighted this, it's not about walking around terrified of every little decision.
Right, like analysis paralysis.
Exactly. It's more about, like, taking a step back and appreciating the way things are connected.
Yeah.
Recognizing those connections.
And maybe even appreciating how those unexpected things, the moments in life that didn't quite go according to plan, maybe those moments have actually led us to some pretty amazing places.
Without a doubt. And hey, we might not be able to control the wind or even predict it half the time. But knowing that even something as small as a butterfly can have an impact, I don't know, to me, that's a pretty powerful thought to carry with you.
I love that. It's about those little changes. Well, on that note, this has been an awesome deep dive. Thanks for nerding out with me on this.
Anytime, really. It's been fun.